Hello! Today I would like to focus mainly on the assembly drawings. So we will go into the steel area. And I have prepared a very exaggerated sample, but let's try with this middle beam, and we will try to dimension bolts, the quite specific task. So we can start from a little different angle. So firstly, let's select the model object. So we will start our work from the model. Then we will try to get all of the drawings connected, which were created from this object. And as you can see, I have probably one assembly drawing. So let's open this drawing with the drawing link. Here it is. So, okay, I have some predefined views without any annotations. I just wanted to make it a little simpler. So I would like to dimension those bolts at this main view. And to make it a little faster, let's just start directly with this view. We could query it, but okay, now I would like to just start with this view. So I have some view. And what we can do now, we should try to extract information what is visible on the view. So we would like to get objects from view. And here we obtained two outputs. The first one is just the type of those objects. So we know that at this view we have some bolts, some connections, some ladder line, etc. But now we would like just to get the bolts, and we see that the bolts are the first branch with this tree. So let's keep it simple and just hardcode the path for this branch. Of course, it could be done with the member set. It probably was in some other video. And now I would like just to get the branch tree. Here's the tree, here's the path, and by doing that, I will obtain only the bolts. And we see that we have 4 different bolts. So let's try to get more details from those bolts. And here we can use those this component, bolt properties. Here it is, but it is working on the model objects, because now in this panel we see bolts which are only the drawing instances. So we can change from that level those kind of settings, but we would like to get more model data. So we have to convert the drawing to the model objects, and we can do it with this drawing to model object component. So this is quite a nuanced change, but now we have the proper model objects which can be connected to the bolt properties. And what we obtained. Okay, so we now know that all of those bolts have the same size. They are associated with the same standard. And here are the most interesting facts. So we have the positions, but hey, those coordinates, they look pretty awful. What is going on? And of course, we obtain those coordinates in the global coordinate system, the world coordinate system. And probably you have not noticed, but just from the beginning of this video, you could saw that this beam, those columns, all of them were rotated in terms of the global coordinate system. So we have to somehow orient those points, and we can do with the standard Grasshopper orient component. So here we just specify the geometry. Here it is, but also we have to specify the coordinate system to which we would like align. So we have to somehow get from this view this coordination system, and it can be done with the view properties. So let's go here, and here we have the view coordinate system and the display coordinate system. Let's just make it simple and let's go with the display. And now let's see, we have transformed those coordinates which were related to the world coordination system to the local, to this particular view. And here, if we can look, we have the first bolt at the 60 millimeters. And what does it mean? It means that if we would measure from this red X and Y symbol, then here we have 60, okay, some running stuff which is not visible with my current Tekla settings, and here it is 110 millimeters. So it is working. Okay, but let's see what we would like to get from this view? Probably we would like to get 3-dimension lines on the left, right, and at the bottom. So let's try to figure out how we can merge this and this bolt, because they should be dimensioned at the same dimension line. And looking only at the positions, it's quite hard to say, because every point from this list is connected to some 3D coordination. So we have to look probably at this direction. Let's see what it is. Okay, so here we have the Z vector from the model. So the vector along which the bolt is placed. So we see that 2 of them are with the global Z. So probably they are this and this. And also we have some awkward stuff. Probably, but we don't know at this point. There are those at the start and at the end of the beam. So we have somehow also changed those vectors to the view coordination systems. And you would like to probably just do it like the previous, but here there is some unusual circumstances. So if you see now, we obtained totally different vectors. It is not. It is not good. Definitely, there is something wrong. So you should know that transformation of the vectors is not the same as the pure geometry, because the vector is an infinite object. It is not exactly here. It is just the line somewhere, and it can be anywhere. So you have to change a little your destination coordination system, because if we would like to see, let's just see what we have here. This is coming from the view properties. We obtained some plane with some origin and some Z coordination system, and we want to just get those directions, those local X, Y, and Z. So how we can do it? So probably we should just get the origin of it. So let's do some crazy stuff and just cast this plane to the point. What we will get by that? Okay, so now we have only the point. And if we, I'm not sure that we should add or subtract. Probably let's at first add. Let's try. And here it is, and now, yes, it was the addition. So we have added to our vectors from the global coordination systems this origin of the targeting plane. And here we obtain something which is good, which is working for this particular view. So at this particular view, we have 2 bolts with the upside direction. So this one and this one, they have only the Y coordinate positive, so they are aligned upside, because here we are working on the plane coordination systems with the X directing onto the right and the Y directing to the top. And next, the third bolt is connected, is oriented to the left side, the negative X coordination. And the last one is the positive X, so it is probably this. Okay, so now we have those orientations and we can somehow group them. And that's the current issue, how we can group them. And probably in Grasshopper there are multiple ways how it can be done. I think that we should use something from the member. Let's just create the member set. Create the set, yes, here it is. And what is the set? Let's see both of them. So the set is the collection of the unique values. So now, after creation of the set, we obtained only the unique elements from this input list. And now we have also the map. So we knew which original list items are mapping to the new set items. And it can be useful. So let's do it, but probably not in this video. See you tomorrow. Thanks.